Hello students, welcome back. So now we're going to be talking about identity matrix, transpose of a matrix, determinant of a matrix, and inverse of a matrix. So identity matrix, it is a square matrix. It has 1 on the main diagonal and 0 everywhere else. That's what your identity matrix looks like. For example, a 2 by 2 identity matrix will look something like this. It will have 1 on the diagonal and rest of the elements would be 0. A 3 by 3 identity matrix will look something like this. You will have 1 on the diagonal and rest of the elements, they're all 0. You can see that they're all 0. A 4 by 4 identity matrix will look something like this. You will have one, two, three, 4 elements, 4 rows, and 4 columns right there. So let me just draw this real quick. And then you will have 1, 1, 1, 1 on the diagonal, and rest of the elements are all 0, 0, 0, 0, 0, 0, 0, 0. Now, a key property of your identity matrix is this. If you take any matrix A and you multiply by identity matrix, or if you take identity matrix and multiply by A, you will get back A. So all this thing is same. So it behaves like a number 1. So if you remember in your high school math, you multiply 2 by 1 is same as 1 times 2 is same as 2. So think of this 1 right here. That's your identity matrix. Let's take a look at this example. Suppose this is your A and this is your I right here. This is my A right there. And I'm multiplying these two matrices. So when you perform your regular matrix multiplication, A and I, so you will get a matrix like this right here. You can perform your regular matrix multiplication. And when you solve it further, you will see this is your answer right there. And this 2, 3, 5, 7, this matrix is exactly same as this matrix. You can perform the computation. Let's take a look at this one. Here I'm doing I times A. Here I did A times I. Okay, now I'm doing I times A. So in this case, when you do matrix multiplication, perform your computation, and you will get back this same matrix A right here. So A times I equal to I times A equal to A. This is one of the key property of your identity matrix. And then you have transpose of a matrix. What it does, it swaps rows and columns. So for example, let's say you have a matrix A and you want to transpose that. So this will be written something like this, A, and then you put T on top of that. So for example, suppose this is your A right here. This is your matrix A and you want to transpose that. So this 1, 2, 3, this becomes like this 1, 2, 3, and this 4, 5, 6, this row, it becomes a column 4, 5, 6. So in this case, your rows and columns, they have swapped. So your rows, they turn into columns, and your columns, they turn into row. Now your size also changes, by the way. Here my size was 2 row and 3 column. Here my size has become now 3 rows and 2 column. So your size, it changes from m by n to n by m. So if this is your A, this is your size of your A transpose. And now comes the determinant. Well, determinant is a single number that is computed from a square matrix. And the notation is this right here. You can say det A, or you can use this notation with the vertical line around A. So for example, for a 2 by 2 matrix, let's say this is your matrix A, the determinant is calculated like this. You multiply A by D minus multiply B by C. This is the formula for determinant for 2 by 2 matrix. Let's take a look at this example. Here I have this matrix A, and you want to calculate determinant of this. So it's going to be 2 times 4, 2 times 4 minus this 1 times 3. And the answer comes out to be 8 minus 3 equal to 5. So this is the determinant of matrix A. And then you have inverse of a matrix A. The notation is this right here. So if you want to calculate the inverse of a matrix A, this is the notation that is used to actually denote inverse of a matrix A. Now, one of the fundamental property of inverse of a matrix is this, that if you take A and multiply by A inverse, or if you take A inverse multiply by A, it will give you back your identity matrix. Think of this as 2, as a number 2. If you remember from a high school math, 3 multiply by 3 inverse, okay, is same as 3 inverse multiply by 3, which gives you 1 right here. So think of this way. This right here is your inverse matrix. So in high school math, we denoted inverse of 3 as 1 over 3. Now, one of the important condition to find an inverse is that a matrix, it has an inverse if and only if your determinant A is not equal to 0. If your determinant of that matrix is 0, you cannot find the inverse. So what is the formula for inverse of a matrix? Well, for 2 by 2 matrix, this one right here, this is the formula. Your A inverse is given by 1 over divided by AD minus BC. Another name for this expression right here is called determinant of A. If you think about it, exactly that's what that was. This was the determinant of this matrix. And then you say D minus B minus C minus A. So this is the formula for A inverse. Let's understand this through a simple example. Suppose this is your matrix A. And so first thing you do, you find your denominator, you find your determinant. This is my determinant, and then you find your inverse. Your A inverse is going to be 1/5, and this is 3 minus 1 minus 1 minus 1 and 2 right here. So I'm essentially using this formula right here. Okay, I got my A inverse. Now, how do I know that this A inverse is the right A inverse? Well, if you remember, I was explaining you that you take A and you multiply by A inverse, and that should give you your identity matrix. And that's what we're doing over here. We're trying to verify. So I'm taking my matrix A, that is this right here, and I'm multiplying by A inverse. That would be this right here. So take this A, multiply by A inverse. Now, this is my just a scalar number. I'm just putting the scalar number outside right here. And then this is my matrix A, and then multiply by this matrix. And when you do this matrix multiplication, your answer will come out to be this right here. And this is exactly your identity matrix. So I just showed you that A times A inverse is equal to your I. By the way, you can also verify that A inverse multiplied by A is still going to give you I. So this is your assignment. Now, where do we use these concepts? Well, these concepts can be used in solving equation. This is one of the application. Suppose you have to solve this equation, 2x plus y equal to 5 and x plus 3y equal to 6. You have this equation. Well, you can write this equation in the matrix forms like this, ax equal to b. My a in this case is going to be 2, 1, 1, 3, and my x, this x right here is going to be xy, and my b is going to be 5, 6. So if I expand, if I take this matrix right here, and I expand this thing, I'm going to get this thing. So basically what's happening is that 2, that's this 2, and this is the coefficient 1 over here. So this is 1, and there's a coefficient 1 over here. So that's your 1, and then there's a 3 over here, and this is your 3. This is how you get these numbers. And then you have x and y, so this is my x and y. And then you have 5 and 6 right here, and this is how you get 5 and 6. So this is how you write this equation in a matrix form. Okay, after you write this equation in matrix form, then you solve this equation, x equal to a inverse b. And in that, in order to solve this equation, you need to know a inverse. Well, I showed you how to find a inverse. So suppose you found the a inverse of a, and this is your a inverse. And all you have to do now is just multiply a inverse by b. You already know your b is 5, 6. So perform your computation right here, do your multiplication, and your x will come out to be this number right here. So the value of x is 1.8, value of y is 1.4. This is my solution for that equations.